Okay, so this is our third video on writing different formulas or compounds, but this one is using polyatomic ions. Now, the word poly means many, so this is an ion that doesn't just have one element in it. This will be called the orange and blue sheet. That's because when we color code it in class, when we color coded to learn how to use it, in class, we highlighted them orange or blue. So you do need to know those by heart. And so the first thing that we're going to do is use polyatomic ions to do names to formulas, right? So you eventually will only be looking at a regular periodic table if you are in honors chemistry. So this is the periodic table that you will get, and the only one that you will get to tell whether or not the item, what its charge is and where it's located, and whether or not it has 4 oxygens or 3 oxygens is going to have to be determined by looking at this particular periodic table. If you are in regular chemistry, you will get to hold on to during your test this orange and blue chart, which is the chart we use to memorize the different ions. This is not a video on how to memorize those ions. There is a video on how to memorize which ones are orange and which ones are blue. Go find that one if you do not already know how to memorize which of the compound ions come from the orange section and which ones come from the blue, because that matters on whether or not it has 4 oxygens or 3 oxygens when it says 8. Once again, that's a totally different video. Go find it first if you do not know how to figure out the orange and blue ions. All right, this is how to use those ions to write formulas. All right, so let's do one example together, and then we'll do a series of practice problems. All right, you have to know your orange and blue ions. So at this time, you can go ahead and take out your orange and blue ion sheet, but eventually you will need to know them unless you are in regular chemistry. Okay, so I've got potassium nitrate. How do I know that this is polyatomic? The way I know that it is polyatomic is because it's ending here in 8. So I know that that has more than one element in that part of the ion. So the first step is the same as it was in writing formulas before, which is symbols and charges. So you're going to write symbols and charges. So the symbol and charge for potassium is K and a +1. I know that because potassium is one of the weird 11. Nitrate, I find it on my chart or I have it memorized. NO3 -1. That's symbols and charges. The second step is reduce if you can. Well, 1 and 1 don't reduce, so I am reduce if possible. And then drop to the bottom as you switch, so switch to subscripts. Remember, there is also a step that lets you know you don't have charges down there. So when you switch to subscripts, you are not putting the plus signs. So the K is going to get the 1, which we don't write, and the NO3 is going to get the 1, which we don't write. And so my formula for potassium nitrate is going to be KNO3. What's important about this? The K and the N and the O are all separate elements and therefore must be all capital letters. There's no spaces between the K and the N or the N and the O, or between the O and the 3. This is all one word now. This is the word potassium nitrate as a formula. So there's no spaces in there. All right, so I'm going to give you a problem to do, and then you are going to write the formula. Remember, the steps are symbols and charges, reduce if you can, switch to subscripts. Remember, we never have charges in there, so there's technically another step that reminds you to get rid of the charges. Okay, so calcium phosphite. I know this is polyatomic because it has ITE. ITE means it is the lower version of the polyatomic ions that you memorize. So pause the video and solve the problem and come back after you have the formula. Okay, first step, symbols and charges. Ca plus 2, PO3 minus 3. The 3 is because of the ite. Phosphate was PO4, so one less is phosphite. Second step is reduce if you can. 2 and 3 cannot reduce down. Third step, switch to subscripts. Now when I switch, and my 2 and 3 can't be reduced, so that's what they're telling you there. When I switch to subscripts, the Ca gets the 3, and the PO3 is going to get the 2. Because you would not write it like this, Ca3, PO3, 2, because then it would look like you had 32 oxygens in this formula. So the rule is, whenever you are going to switch a number, a subscript, to something that is polyatomic, more than one element, if the number you're switching over there is not a 1, if it's any number, it's not a 1, then I have to put my polyatomic in parentheses. Okay, I don't want to just say I need more oxygens. I actually am saying I need 2 PO3s to balance out my 3 CAs. So whenever the subscript is not going to be a number 1, I have to put the polyatomic in parentheses. All right, let's give it another try. You're going to write the equation for copper 1 fluorate. So pause the video and come back and see the solution. All right, first step, symbols and charges. So copper with a Roman number 1 is a Cu plus 1, and fluorate is an FO3 minus 1. Reduce if you can. I can't, they're both 1s. Drop to subscripts, switch to subscripts. So Cu gets the 1 and the FO3 gets the 1, neither which you write. And when you are putting 1s, you don't put parentheses. So Cu FO3 is the formula for copper 1 fluorate. All right, another problem. Zinc bromite. Pause the video and come back after you get your solution. Okay, first step, symbols and charges. Zn plus 2, BrO2 minus 1. Reduce if you can. There's no reduction because Br is already a 1. Drop to subscripts, switch to subscripts. So the Zn is going to get the 1, which we don't write, and the Br2 is going to get the 2. And because it is a 2 and not a 1, I'm going to have to put the Br2 in parentheses. Okay, so that's where that 2 is coming from. It's coming from the zinc. I don't just write 22 after the oxygen. And I don't just put the oxygen in parentheses. It's the whole thing. And that's all one word now. Bromate is one thing. Don't separate it. All right, next formula to solve, nickel 3 borate. Pause the video and come back and get the solution. First step, symbols and charges. So Ni plus 3, borate, BO3 minus 3. Reduce if you can. Both of them cancel out. 3's divide by 3, and they both reduce down to 1s. Then nickel gets the 1, which you don't write, and the BO3 gets the 1, which you don't write. And my answer is NiBO3, and there's no parentheses because there's only 1. Be careful. There's a lot of people that write it like this, NiBO3. That would be completely wrong. okay? Because this is implying that this is an element that has two digits in it, a B and an O, and there is no BO on the periodic table. You cannot write it like that. You can't say, oh, well, there isn't one, so it's okay. No, you cannot write the oxygen a lowercase o. It has to be the same height as your other uppercase letters. So double check that. That's one of the most missed things in writing polyatomic formulas is the capitalization of your oxygen. Okay, so be careful on that. All right, so let's go the opposite direction. We've been given the name manganese 3 tungstate, and now we want to write the formula. So first step, symbols and charges. Second step, reduce. Third step, switch to subscripts. So go ahead and pause the video and come back and see the solution. The answer is Mn with the little number 2 subscripted, parentheses, WO4, and parentheses, excuse me, with a 3. Again, another problem, barium sulfite. Pause the video and come back for the solution. All right, here's your solution. Iron, Roman number 2, iodide. Now that says iodide. It didn't say iodate or iodite. So hopefully you remember this is the old naming system, the one we learned on the very first week in the very second lesson that we learned. So iodide is just the letter I. It's not iodate and it's not iodite. Excuse me. So there's no oxygen with it. So still symbols and charges, reduce if you can, switch to subscripts. Now here is a little bit trickier one because this says ammonium selenate. Ammonium is in the periodic table on the orange and blue chart in the little box that says noteworthy additions. Its symbols and charges are NH4 plus 1. So, and then selenate is an SeO4 minus 2. So I'm going to, and the NH4 with the plus 1 is going to give the number to the SeO4, and the SeO4 is going to give its charge to the NH4. And you'll see, just like when the ion was a negative ion, when you have a positive ion and you're giving another number, I have to put that positive ion in parentheses. All right, now we're going to go from formulas to names. All right, same deal as when we had single ions. We just now have polyatomic ions. So, first thing, write the name of the cation. That's Mg, so that's magnesium. Second, you're going to ask, just like we did before, is magnesium a liar? Is it one of the ions that have multiple charges? If it is, you would leave parentheses. If not, you're going to skip down to 5. If it was, the reason that you left parentheses is you have to figure out the charge of it by uncrisscrossing it, and then you're going to name the anion. All right, so in this one, the steps are magnesium. It is not a liar, so skip to number 5. SO4 is sulfate. So the answer to this is magnesium sulfate. Let's try another one. First step, write the cation. What's the cation? Fe is iron. Fe is iron. So the iron is a liar. So I'm going to put parentheses. So I have parentheses, And when I put parentheses, I come back again to figure out what number goes in the parentheses. It is a liar. It's got more than one charge above it. Then the iron, it has a Roman number. I'm going to put parentheses. Then I'm going to look to unswitch it. So I'm going to come up here and I'm going to say Fe got a 3 from the ASO3. And if that's true, then the Fe gave a 2. And it was true. So it's arsenite is the ASO3. It does have a 3. So my answer is iron, excuse me, Roman number 2, arsenite. So there's the switcheroo. So ASO3 is a 3, then the Fe is a +2. All right, so try this one, pause the video, and come back and see the solution. So Au is gold. Gold is a liar, so Roman numbers. NO3 is nitrate. Nitrate is a 1. Does it look like the nitrate gave a 1? Yes. So the gold gave a 3. Gold 3 nitrate. Next question. Pause the video and come back and look at the solution. Okay. Ba is barium. Barium is not a liar. So there's going to be no Roman numbers. SeO3 is selenite. Barium selenite. Another problem. Al, SbO4. That's aluminum antimonate. So Al is not a liar, so no Roman numbers. Antimonate is SbO4, is antimonate. So another problem, pause the video and come back for the solution. Cobalt. Cobalt is a liar. Do the switch and see what numbers are here. So is CO2 a -2 charge? Did it give the 2 and not reduce? Yes. So cobalt, Roman number 3, carbonite. Another practice problem. Pause the video and come back for your solution. Cadmium nitrite. Cadmium is not a liar. There are no Roman numbers. Next problem. Pause the video and come back for the solution. Potassium chlorite. Potassium is not a liar, so it does not have Roman numbers. Potassium chlorite. There are some other things that the halogens do. The halogens are the column that is right next to the noble gas column, and they not only have your normal ate and ite varieties, but they have a perate and a hypoite varieties. This is not the video on how to memorize that. This video indicates that you already know that. So we're going to proceed on with our formulas. If you do not know your orange and blue ions, you really need to make sure you do. So here's the question. Copper, Roman number 2, perfluorate. First step, symbols and charges. Second step, reduce if possible. Third step, switch to subscripts. Pause the video and come back for your solution. So copper is +2, fluorite is -1. That's not reducible. Switch to subscripts. Copper gets the 1, which you don't write, and the perfluorate gets the 2, which has to be on the outside of parentheses. Here's another solution. Zinc hypobromite. Pause the video and come back for the answer. Zn +2, Bro -1, no reduction possible. Zn gets the 1, which you don't write, and the Bro gets the 2. This must be in parentheses. Even though 2 looks like a normal number that you could have on an O, please keep in mind if the 2 was on the O, that would look more like bromite, not hypobromite. You must use parentheses when you have more than one polyatomic in the formula. All right, some more practice problems. Come back for the solution. Pause the video. SR parentheses IO4 parentheses 2. That's the formula for strontium periodate. Ca parentheses ClO and parentheses 2. Write the name for this formula. Pause the video and come back with the formula name. Okay, calcium is not a liar, so there's no Roman numbers. Calcium hypochlorite. Another practice problem. Pause the video and come back for the solution. You should have known that this was sodium periodate. Hopefully you have done well on your practice problems. If not, you'll need to learn your polyatomic ions.